Good morning, everyone. Present here on this auspicious occasion. The fourth and final day of the National Conference organized by Good morning to everyone. Present here on this auspicious occasion. Good morning to everyone. Sorry for the technical interruption. Good morning to everyone present here on this auspicious occasion. The fourth and final day of the National Conference organized by Postgraduate and Research Department of Mathematics. Argadas Govardhandas Vaishnav. To begin this day, let us first invoke our mother Tamil and then the presence of the Almighty, without whose guidance this program would have been just black and white. May I now request you all to raise your feet for Tamil Thai Valda, followed by our college prayer song.
நீராறும் கடலொடுத்த நிலமடந்து எழிலொழுகும் சீராரும் வதனமென திகழ்வரத கண்டமிழே எக்கணமும் அதிசிறந்த திராவிடனல் திருநாடும் தக்க சிறு பிறை முதலும் தரித்தனரும் திலகமுமே அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே உன் சீரிழமை திறம் வியந்து செயல் மறந்து வாழ்த்துதுமே
सत्यव्रतं सत्यपरं त्रिसत्यं सत्यस्य योनिं निहितं च सत्ये सत्यस्य सत्यं ऋतसत्यनेत्रं सत्यात्मकं त्वां शरणं प्रपन्नाः वाणी गुणानुकथने श्रवणो कथायां हस्तौ च कर्मसु मनस्तव पादयोर्नः स्मृत्यां शिरस्तव निवास जगत्प्रणामे दृष्टिः सतां दर्शनेस्तु भवत्तनूनाम् नमो भगवते तस्मै कृष्णायाद्भुतकर्मणे रूपनामविभेदेन जगत्क्रीडति यो यतः ॐ शान्ति शान्ति शान्तिः.
Mathematicians or in people find math easy. They are people who enjoy how hard it is. I am profoundly delighted to take an opportunity to introduce one such mathematician. The very first topic we are going to listen and learn from him is Hamiltonicity and its variants, complexity and computing. I extend a very warm welcome to Dr. N. Sadagopan, Assistant Professor and HOD, Department of CSE, Indian Institute of Information Technology, Design and Manufacturing, Kanchipuram, who readily accepted our invitation and joined us today to be a part of this conference. He pursued his BE in Computer Science and Engineering from Dr. MGR Engineering College, Chennai. He completed his MS degree and PhD in IIT Madras under the guidance of Dr. N.S. Narayanaswamy. Moreover, he was a postdoctoral researcher at Indian Institute of Science, Bangalore, from June 2012 to July 2012. His area of specialization is theoretical computer science. His research areas are graph theory and combinatorics, computer networks, data structures and algorithms, database systems, graph library, generation package. He has published numerous research papers and conference papers in these fields. He was awarded as an outstanding teaching assistant for the course Mathematical Concepts in Computer Science from the Department of CS, IIT Madras for the year 2008 to 2009. He has secured All India rank 592 in GATE 2005. He was a reviewer of Balcom 2013, ICO-NDM 2013, CalDEM 2016, Discrete Applied Mathematics 2013, 2015, and Oxford University Press. He is a member of BTech Project Evaluation Committee, NIT Trichy. He is also a member of Board of Studies, Government of College Engineering, Trivandrum, and Academic Affairs Council, IIIT Kurnool. Coming to his work experience, he was a lecturer at Sri Venkateshwara College of Engineering, Sri Perumbudur, Chennai from November 2003 to July 2005. He was a half-time teaching assistant at IIT Madras for various computer science related courses at undergraduate and graduate level during 2005 to 2011. And then he became an assistant professor at Sri Venkateshwara College of Engineering, Sri Perumbudur, and was there till June 2012. At present, he is working in Indian Institute of Information Technology, Kanchipuram. No doubt, we are honored to have him today with us. So without consuming any time, I hand over the session to Dr. N. Sadagopan. Sir?
Thank you. Thanks for the introduction. Let me start the session. Is my screen visible to all? And I'm also sharing a whiteboard in case any doubts, clarifications, I'll write over here. Is both screens are visible?
No, sir.
No.
Sir, please share your screen, sir.
Yes, I am done.
Yeah, now it's visible, sir. Your screen is visible.
Okay, fine. So very good morning to one and all. So the objective of this talk is to introduce you to some specific problem in graph theory, and I assume you have some exposure to basic mathematics and graph theory. Even if it is not there, you don't have to worry, because the objective of this talk is to motivate you, and so that you find this talk interesting or these problems are interesting, and kind of, here and there you will also get some inspiration. And with that, you are an undergraduate student, you may like to pursue further as part of your MSc program, or you're an MSc student, you may willing to take up PhD in graph
Excuse me, sir.
theory. Yeah, please.
Sir, your video is not visible, sir.
Yeah.
Your face, screen is visible.
Is it clear?
Yeah,
Is it
it's
visible?
now okay, sir.
Yeah,
Okay.
yeah, yeah. So the objective of this talk is to expose you to some specific field in mathematics, in particular graph theory. And along this presentation, you will also get some inspiration. With that, you may willing to take up further studies on graph theory as part of your MSc or PhD research. So I've taken a specific problem so that you get to understand what it takes to do or research a topic in graph theory, and how to ask a question, and how to take that question forward, and what all strategies one can employ to arrive at a solution. And so the problem or the graph class, it's only a handle or a sample. And you can, the techniques or tricks that you learn through this presentation, you can employ anywhere else. Okay, so with that, I'll start my talk. I'm going to talk about Hamiltonicity and its variants. It's a classical problem in graph theory. The motivation came from electrical engineering. If you look at any circuit boards or computer science, if you look at design of computer networks, they're all circuits. You have nodes and edges. And nodes and edges in the context of computer network, you can view it as routers and Ethernet links. In the context of computer architecture design, you can see it as chips and then the interconnecting electrical line, things like that. Now, there are many fascinating problems which we come across as part of electrical engineering or computer science. And to arrive at a solution, what we do, often we model them as an appropriate problem in graph theory. So that's where graphs are powerful. As far as mathematics is concerned, we always give importance to two things. One is abstraction. What we speak should be abstract in nature for two reasons. It should be unambiguous, and what we speak should be clear. There should be clarity in what we speak. And most importantly, when I speak something and you get to understand, which means there is a logic in what I speak. So we also give importance to logic when we speak. Then when we try solving a problem, modeling is very, very important. So you look at a plant and you wish to know what is the rate of growth of that plant. So today you plant something at your place, and you wish to know what would be the growth after a year, and after 2 years or 5 years. Or you look at some statistics and you predict what would be the growth of this coconut tree after 10 years. So naturally, it is rate of change. You model using appropriate thing in calculus domain. So like that, we come across many mathematical models in the field of mathematics. Graphs are a powerful model in modeling many problems in electrical engineering and computer networks. As such, if you see the problem, then you may think the problem is difficult, or you may not get any handle to proceed further. But the moment you model it in graph theoretic setting, it's kind of, problem is solved, which is why people prefer graph models for a variety of applications. So with this motivation, why graph theory, why modeling, and why abstraction, let me get into the specifics. So is my audio, video, and what I speak, is it clear to everyone? Can someone respond? Yes or no? Anything is fine.
Yes, sir.
Is everything okay?
Yes, sir. Yes, sir.
Okay, very good. Yeah. let me introduce some terminology before I switch to this. I'll stop my video so that you get full bandwidth for my audio. If required, I'll switch on. Yeah.
Okay, sir.
So trees are connected acyclic graphs, and which you must have seen in many contexts. What is a spanning tree? A spanning tree is a tree that spans all of V of G. We talk about something called Hamiltonian cycle. What is that? It's a spanning cycle. So given a graph and you say here is Hamiltonian cycle. So that cycle starts at a vertex and visits all other vertices exactly once and come back to the root. So such a cycle is known as Hamiltonian cycle, and it was discovered by the scientist Hamiltonian. Motivation comes from many domains. One simple application, look at say a salesperson or Swiggy or courier man. What he does is he starts from his collection center and he arranges his letters or parcels in some specific order. So, and he has to visit all these places where he has to deliver houses or some distribution center in some specific order, but he will visit each of them exactly once and then come back to his source or the collection center. Now, natural questions are, now can you come up with such a tour? Such a tour, is it always exist? And if such a tour does not exist, how do you, you want to distribute these parcels? So if that's the case, you may have to come back to the distribution center multiple times. That's one. Suppose such a tour exists and you may find many tours. And which tour will you go for? So naturally, you will look for something that will take least time. So I start at 9 in the morning, and if I could deliver all parcels in say another 1.5 hours time, then I would be the happiest person, so that I can come back to my collection center and start delivering the next set of parcels. So there are a variety of applications. I've given you one such application. So you say a graph is Hamiltonian. Now, when you say a graph, the underlying application could be maybe a traveling salesman problem, maybe a courier boy problem, maybe Swiggy person trying to distribute parcels. It could be anything. So all of this is converted into a graph. And say I start at Arumbakam, then I have to deliver a parcel at say Coimbatore, then I have to deliver a parcel at say Vadaparni, then somewhere in Guindy. So each place in the city gets a node, and the road link connecting Vadaparni and Guindy is precisely an edge. The weight of the edge will tell you the distance. So that's all. You get a simple model, and now you can ask for, does there exist Hamiltonian tool on this graph? So this is on one side, and modeling is on one side. So what next? Why did we model? So modeling is, the purpose of modeling is to solve something, to take you to a solution. That's where computer science is powerful. That's where algorithms are powerful. So often we are interested in finding such a solution, finding a Hamiltonian cycle. So can I find that efficiently? Can I find that in easy time? Meaning, can you come up with a solution which will output in say 15 minutes time or in 20 minutes time? Or is the problem so complex that it will take say 5 hours to get a solution? Or is the problem is so complex that it will take 2 days to solve this problem? But these are all in layman's language. Formally, if the problem is difficult, we say that it is NP complete. There is a separate theory called NP completeness theory. So we may not have time to expose you to that track, but you remember that if the problem is said to be NP complete, then the problem is difficult to solve. It has a solution, but it is difficult to solve. In terms of time, you can assume to get a solution, you may need some say 5 hours or 10 hours. If it is easy, then it is in say minutes or seconds. So something like that. So when we say a problem is set to polynomial time algorithms, so something like order n square or order n cube, they are all polynomial with respect to input size. And in layman's language, polynomial time algorithms meaning easy algorithms. NP complete meaning difficult algorithms or something it's hard to solve. That's all. But you come across Hamiltonian cycle problem in almost every application that you come across. Traveling salesman tour or Swiggy tour is a fundamental problem. So naturally, although it is difficult, somewhere you have to cope with this to look for some handle to handle these problems. Let's see. If a problem is known to be NP complete, what directions one can take to approach that problem? So you are asked to solve a puzzle or some problem. You try for some time and you think it is difficult. One simple thing, you just give up. But that we should not do. As a researcher or a mathematician, curiosity is driving you somewhere, right? So you have to be curious and look for some alternate tracks. Can I somehow approximate the solution? Can I restrict my input and then look for a solution? For example, you are asked to solve some problem on the set of, say, real numbers. Say you find it difficult. You can restrict the input and say, look for the study of that problem on the set of natural numbers. Even on the set of natural numbers, you find it difficult. Restrict further. Maybe focus on set of even numbers. You find it even difficult. You just focus on numbers that are, say multiple of 5. So like that, you keep restricting the input so that you get some clue or handle on how to approach the problem. So similar thing is what we do in graph theory as well. See, when I present, I also give you some messages. For example, when a problem is difficult, you should not give up. You should look for directions through which you can, look for an alternate solution by restricting the input, by compromising on the quality of the solution. So these messages you should remember and apply in your research. You may be doing research and analysis. You may be doing research and machine learning. But this message will be of use when you look at appropriate problem in your favorite domain. Okay. Yeah. So having highlighted the complexity of Hamiltonicity, now and then I've given you that there are a couple of alternate directions one can take when the problem is difficult. Let me highlight a couple of them. There are variants and generalization which we come across in the literature. One problem is called longest path. If you look at Hamiltonian path, Hamiltonian cycle is a circuit. You come back to the source. Hamiltonian path, you start at the source and visit every other node, which means if you look at the number of edges, the length of the path will be n-1. Suppose you are unable to find such a tour, then naturally you say, yes, a salesperson says, sir, I cannot cover all of this in one go. Then we naturally ask, try covering the maximum number of places in Chennai when you start at 9 o'clock. Between 9 to 12, you try covering the maximum number of distribution centers or collection centers. So that is called the longest tour, longest cycle, or longest path. Okay. And the other problem is coined by the scientist Steiner. So what he says, I am not interested in the entire network. I am interested in a specific sub area. For example, you go to, say, Tambaram, and you look at places around Tambaram, say Peragaluthur, Vandalur, Maraimalai and so on. You ask, is there a way of visiting the places around Tambaram in one go? So in graph theoretic setting, I'll give you a graph and a subset of vertices, can you visit these subset of vertices in one go? Meaning, can you look for Hamiltonian path for that subset? That problem is called Steiner path problem. So these are all the variants that people have looked at great length in the literature. But let me touch upon literature and tell you who has done what is the current status, so that you wish to take this problem as part of your research, and these things will be of use. So here is a complexity status. Down I have given you the reference. So I'll also share this PPT so that you can go back and Google these papers. So Hamiltonian path, cycle, its variants, generalization, they're all quite interesting, and have been on research for almost 50 years. And even today it is active because of its applications, promising results, and so on. So all these problems are NP complete for general graphs, and even on special graphs like split Gödel bipartite graphs, the problem is difficult. So when you are working on a problem and you find that it's kind of difficult, you should pause and start asking questions, which is precisely what I'm doing now. So some interesting questions. How do we cope with NP completeness? What next? What is that one can do when we know that so and so problem is difficult or is NP complete? Now, can you draw a boundary line separating easy versus difficult instances, separating the P versus NP complete instances? So that line of research is called dichotomy. And you think this may not be a promising direction, so can I restrict the input? Can I look at special graph classes? For example, what is the complexity of Hamiltonicity in well-known special graph classes like interval graphs, Hoare graphs, two trees, and so on? And as a mathematician, we are always interested in structural graph theoretic questions, something that involves pure math, because we are fond of writing proofs, and in particular writing proofs using mathematical induction, proof by contradiction, and so on. So that gives you some enlightenment. So for some, eating a cake or spending time with friends, but for some, writing proofs, writing programs gives enlightenment, right? And for mathematician, it is always proofs, and then in particular proofs based on mathematical induction and proof by contradiction, and so on. So can we think of necessary and sufficient conditions for Hamiltonicity in special graphs? So as part of my research with my PhD students and a couple of undergrads, I've done some work. And let me highlight those results as part of this talk, which will motivate you, which will inspire you, so that, because it's all done by students, right? So then you get to see that, yes, I'm a student, why not me? And I'm a MSc student, having seen this, why don't we attempt, say, a PhD at so-and-so institute? And you can apply for a PhD program at, say, IITs, NITs, IIITs. With full funding, you can do great research for 5 years, and you can join some college as a faculty, and you can continue that chain reaction. So now you are a shishya of someone, then after some time you will become a guru, and then you start working on some specific problems, and you will have a couple of shishyas, right? And this chain continues. Yeah. Let me touch upon the work that we carried out for quite some time on these problems. So far, any doubts, clarifications? Are you all with me?
Yes, sir.
Okay, good. Any other suggestion in case am I going fast or things are not clear? Please let me know.
Okay, sir.
Yeah. So here is a split graph. A graph is said to be a split if it has two partitions. One partition is a click, it is complete, whereas the other partition is an independent set. Okay. Here is an example, and the one that is labeled K is click. It's complete in some sense, and the one that is labeled I is an independent set. It's a special graph which we come across in in the design of computer systems. And now we wish to study, say, Hamiltonicity in this problem. Is it difficult or is it easy? Okay. So what we have shown as part of our research is Hamiltonian cycle is NP complete even for special graph like split graph. Even for special graph like K153 split graphs. But natural question is, are there some special split graphs where the problem is easy? Answer is yes. The second bullet says Hamiltonian path or cycle is easy or is in class P for K143 split graphs. So remember, as part of my interesting questions, I've told you my second question was, can we come up with a borderline separating P and NPC? Answer is yes. We were successful for Hamiltonian cycle as well as Hamiltonian path as far as K153 split graphs are concerned. So what is this telling you? Even you can take one special graphs and this problem and study this P versus NPC dichotomy. And you get a paper, that's one side. But more than that, there is a learning. There is a learning in trying to apply what you have learned as part of a basic course on discrete mathematics or basic course on graph theory, which you must be doing now or later or must have done as part of your BSc or MSc. So on one side you learn concepts, but somewhere you have to apply. Where do you apply? When you start doing research, which is why people are fond of doing research. When you start applying, you get to understand your fundamentals. You get to understand where you stand. You get to understand how to apply. And you are unable to apply, but which means what? There is some clarity missing in your understanding. So you go back and read again. So which is why often repeated reading will help you to get clarity on a particular topic. Once you have the desired clarity, it comes to application. When it comes to application, you are the champ. So often the clarity drives you curiosity, and curiosity drives you invention. And here is one invention. So how are we able to show these results? You must understand mathematics is so powerful, and irrespective of the domain you are in, be in computer science or electrical engineering or physics or chemistry, without mathematics nothing can be done. And having given that, the power of structural graph theory is so crucial and in solving or improving many claims in algorithmic graph theory. So I'm not going to prove any of these theorems, but I'm just giving you a picture that structural graph theory plays a crucial role when it comes to algorithmic graph theory. So what you study as part of discrete mathematics, proof techniques, relations, functions, and what you study as part of advanced combinatorics, all that will come in some form when you start doing research in graph theory. Okay. So you may wonder, why am I studying this course? Is it just for the sake of grades? No. When you start doing the research, you get to see the power of discrete mathematics and the power of combinatorics. Here is a claim. So we looked at K1 free split graphs, K1 free split graphs, K1 free split graphs. For K1 free and K1 free, we have shown it is easy. Whereas for K1 free, we have shown it is difficult. When we say easy, we have to give a condition. When will the input graph as a Hamiltonian path or as a Hamiltonian cycle? what properties or what conditions should the input graph satisfy to have the existence of Hamiltonian path or Hamiltonian cycle. So that's precisely what I'm giving you as part of these theorems. Again, get the message. I'm trying to convey the following message. To talk about existence of Hamiltonian path or Hamiltonian cycle, you need the structural understanding. You need appropriate claims, lemmas, theorems, proposition from structural graph theory. And in front of you, there are two such results. Using this, you can discover an algorithm, and the output of the algorithm will be the desired Hamiltonian path of the input graph G. Okay, so often you may have to give multiple conditions, and if all of them are satisfied, only then you can ensure existence, and that may require deep understanding of the graphs. You may have to draw many graphs to extract patterns. You extract some interesting observations. For example, here is a claim. This says G contains a Hamiltonian path if and only if the following is true. It says it should not have this property, no short II path. So short II path is something like there is no path starting at an I vertex and ending at an I vertex. If I say ik paths, which means it starts at k and it ends at I, or starts at I and ends at k. And you may find many such paths. We say number of such paths should be at most 2. So how did we discover this, and how are we able to prove? By sheer hard work. And if you spend thinking about this problem, say 6 hours a day for say 3 months, yes, you will be able to do it. Okay. So I'm trying to pitch the effort involved in discovering results. Okay. So if you spend something like 6 hours a day for say 3 months, you will also be at your best, and you are also a perfect researcher. Okay. So by sheer hard work and sincerity to the task given to you, and success comes for free. You don't have to define, success. It is hard work and sincerity gives you the desired one. Now that you have made a progress, so often this happens, right? You climb 100 steps, then you get some confidence. Then you think, let me climb another 100. So that is how people climb Everest and so on, right? They start with small mountains, and once they gain sufficient confidence, they start experimenting on big ones. And after that, you think, why don't we try, Everest? There is nothing like failure, right? Even you reach 50% of Everest, then that itself is a progress. So when you discover something, and then you start asking, yes, there is a progress on split graphs, in particular Hamiltonicity. So what more I can do? Because a typical PhD student spends 4 years on a research topic, right? So now curiosity, this is what I was telling you. So now you will be curious to ask some more questions. Curiosity drives you further. So that's when we started asking, so can we focus on some more graph classes? As the problem is promising, can we look at this problem on other graphs? We may not be successful all the time, but let's attempt. And we looked at something called caudal bipartite graphs. A bipartite graph is said to be caudal bipartite if every cycle of length 6 has a chord in it. A chord is an edge joining a pair of non-adjacent vertices in a cycle. Okay, non-consecutive vertices. Fine. So what we thought, let's look at say caudal bipartite graph and see what is the complexity status of Hamiltonicity. So interestingly, we were able to show that it is NP complete for P8 free caudal bipartite graphs. So understand these terms. I'm not getting into the details of how P8 looks like and so on. Then you will be, then the talk will be too abstract. You may not get the details. I'm pitching at a top level so that you are motivated to take up this problem as part of your project or research. So now, having identified NP complete part, natural thing is, can we identify the polynomial easy part? But unfortunately, or fortunately, we were able to solve only a part of that. So it's not complete. Our research is only partial on the easy track. We were able to show that it is in class P for P5 free. We are still working on for P6 free and P7 free. We don't know. It may be complexity class P or NPC, or we may not get the solution in another 6 months or 1 year. I may have to work on this for another 2 to 3 years time. Okay, so I'm just highlighting you the effort involved in discovering these results. Okay, so are you all with me? Any doubts, clarifications so far?
Yes, sir. We are there.
Okay, very good. Feel free, BSc, MSc, PhD students and respected faculty members who have any clarification, feel free to ask.
So participants cannot unmute themselves, sir. They will post in the chat box.
Oh, okay, fine. In case there is a chat message, please let me know, because I will be looking at my screen.
Sure, sir.
Yeah, thank you. So how are we able to achieve these results on caudal bipartite graph? Again, structural graph theory plays a role, and so it's like a twisted pair. The structural graph theory and algorithmic graph theory, they go hand in hand. So one has to have a deeper understanding of graphs or structural graph theory part before you switch to algorithmic graph theory. If you are not making a progress in algorithmic graph theory, which means sufficient effort was not put in as part of structural graph theory. You should go back to structural graph theory and spend more time and have a deeper understanding of the structure before you dwell into algorithmic graph theory. So we were able to show that the vertices in P5 free caudal bipartite graph can be ordered in some unique way, meaning they have something called nested neighborhood ordering. Because of the arrangement, you are able to solve this problem. For example, here is a talk and there are 50 plus audience are attending. Now, when it comes to questionnaire, unless you organize these questions in some specific fashion, and the response would be difficult. Okay? Unless you group them in some form, and the response would be difficult, or it may not be nice. Okay? So organizing vertices or arranging them in some specific order is always useful for a variety of problems, and we did this and we were successful for Hamiltonicity. We were able to come up with Hamiltonian cycle and Hamiltonian path using this ordering. And because the structure is deep, naturally the results you discover will also be not that easy. So we have come up with necessary and sufficient condition for existence of Hamiltonian path in P5 free caudal bipartite graph. We have similar results for Hamiltonian cycle as well. So there is a famous scientist by name Shavtal. He has given necessary condition for Hamiltonicity, but there is no sufficient condition for general graph. So we were asking, can we prove or can we show that Shavtal's necessary condition is also sufficient for these special graphs? So on the structural graph theory front, we always ask for if and only if necessary and sufficient. When you know that For general graph, we only see necessary condition or sufficient condition. And it is natural to ask, can we restrict the input and show necessary and sufficient condition for special graphs? We were successful on that front, and we were able to show that for P5 free caudal bipartite graph, the Chavatal's necessary condition is sufficient as well. Now, similar work has been done by many researchers, and one can ask this kind of study for other graphs in the literature as well. So further, what we did is we extended our work because you have good understanding of P5 free caudal bipartite graphs. So it is natural to look at other problems which are related to Hamiltonicity, namely its variance, generalizations. So we solved these 5 problems. And all these problems are NP complete in general and in class P for P5 free caudal bipartite graph. There are many scientists. There is a scientist by name Dreyfus Wagner. He has done good work on Steiner. And minimum fill-in, there is a scientist by name Clocks. He has done a lot of work on minimum fill-in. So these are all fascinating problems and which has attracted researchers for almost 30 years now. So what you do, you explore, Google these problems and look at the state of the art, the current status, and pitch in your idea onto these problems. So now that we were able to make complete progress on one graph class, split, and some partial progress on the second graph class, caudal bipartite. So what next? Ask questions. So the research is all about asking questions. If you look at Einstein quotes or Newton sayings, they say ask question and to become a researcher. And Newton asked how many we should ask. Einstein says you keep asking. You keep asking until you ask a good question. So when you ask a question, how do you know it is good or it is just a question? Keep asking. It is the answer that decides whether the question is good or not. So being a researcher, we will be curious to ask many questions. So here is the next set of questions. So having seen bipartite graph, can I modify bipartite graph? Say suppose I convert one of them into a click. What you get is a split graph. So question is interesting. The answer is equally interesting. But we have seen nice results on split graph. Now can we make both partitions click? You get something called co-bipartite graph or complement bipartite graph. Now it makes sense. It makes sense to study. Here is a new graph class obtained by modifying the bipartite graph. So can we study Hamiltonicity on these graphs? Most importantly, you are solving some puzzle in, say, mathematics or some problem in mathematics. Say you are asked to find the determinant of a 4x4 matrix. If you look at the determinant of a 4x4 matrix, that computation will involve computation of determinant of a 3x3 matrix, which means solution to 3x3 matrix is being used in solving the 4x4 matrix. So these techniques are called the black box techniques. Can I use solution to one problem to solve another problem? There is a study that says similar problems have similar solutions. Okay, having given this code, so can I relate Hamiltonicity? Can I relate split graphs and bipartite graphs? Can I relate bipartite graphs and co-bipartite graphs? Can I use the solutions of split, bipartite, to solve co-bipartite or bisplit and so on. We've just started this research and we don't have any results on that track. Maybe when we meet next, I can highlight you. But I'm highlighting you that one should ask questions, and so that your research will keep progressing year after year. You continue to work on a specific domain with regular set of PhD students. The last one is interesting. We talk about convex properties in various aspects in mathematics. So convexity brings you ordering. So we thought, why don't we bring convexity in graphs? In particular, bipartite graphs or split graphs. So convexity tells you that you arrange the vertices in some specific order. You arrange them like a chain, you arrange them like a cycle, or you arrange them like a tree. So that problems that are difficult in general may be easy to solve due to this ordering. May be easy to solve with the help of this ordering, which is why convex properties play a role when it comes to graphs. There are many scientists like Aiko Muller. They all have done some work, and Keel, Pradhan. So these people have done great research on this line. For example, Muller has shown Hamiltonian circuits in chordal bipartite graphs is difficult. And he has also shown that on convex bipartite graph, the problem is easy. If you bring convexity to chordal bipartite graphs, the study of Hamiltonicity is in class P. If there is no convexity, then problem is difficult. It is incomplete. So such graphs are known as convex bipartite graphs in the literature. So classical results due to Muller and Keel tells you in convex bipartite graph, in interval graphs, the problem is easy. Now, as a researcher, we are working on Hamiltonian path, longest path, Steiner path, and so on. And you want to explore further and you are interested in these problems, you can collaborate with us as an intern. You can work with us during summer break or winter break, or you are a PhD student. You discuss with your advisor and you can collaborate with us. Okay. And it's a free atmosphere and where we look for collaboration with peer institutes and in taking graph theory research further. Okay, and you are interested in these problems, feel free to contact us. I can give you relevant articles. I can give you some more papers to read. I can come online and through Gmeet, we can have a discussion further on these problems. Okay. So we made some progress and we were able to come up with the, yeah, do you have any doubts? Okay, yeah. So we were able to say that if the input convex bipartite graph satisfies so and so property, then it has Hamiltonian cycle. Again, these results are from structural graph theory. We say you look at the vertices in one of the partitions, its neighborhood should satisfy this property. There should be a lower bound and an upper bound on this neighborhood. And if such a property exists, then the input convex bipartite graph has Hamiltonian cycle. As part of PhD work, one can explore other convex properties. Why linear ordering? Why not a non-linear ordering? For example, I order the vertices in star fashion. I order them like home, and I order them like tree. So for all of them, can we make some progress? This was recently started, this line of attack by Chen et al. and their work appeared in Journal of Combinatorial Optimization. And more on this one can explore. So what is that I've done in last 55 minutes is precisely this. So I've given you a specific problem called Hamiltonicity and two graphs. One is split graphs and bipartite graphs. I've given you what is the complexity status of Hamiltonicity and its variants in these two graph classes. And how was our tour from literature to research gap to discovery? How did we move from the literature to invention? So all that I've highlighted. Suppose you are interested in exploring this study further, here is a set of questions which will keep you busy for say at least 2 years. And then you identify some more questions at the end of 2 years that will keep you busy for another 1 year. With that, you are a material for PhD. You can start writing your thesis and all that. So you are a master student or BSc student, you just take one problem and explore as part of your BSc project or MSc thesis. Okay. Structural graph theory, two questions. One is necessary and sufficient condition. Can we always bound? Can we bound the number of Hamiltonian paths and cycles? And when I started this talk, I told you we may find more than one Hamiltonian tool. Which one would you look for? Will you look for the one that minimizes the cost or the distance or time? So you bring in parameters. And then you ask for which tour I should look for satisfying the so-and-so requirement. Okay. And no restriction. We may find many paths just out of curiosity. On the combinatorial front, you ask how many different Hamiltonian parts are there, how many different Hamiltonian cycles are there, and so on. Then on the algorithmic graph theory front, as mentioned before, one should spend sufficient time on the structural graph theory front before switch to algorithmic graph theory. You start focusing on P versus NPC investigation, and you look at you can look at convex split graphs, and there are similar problems. So this is where I always give importance to similar problems, because similar problems have similar solutions. So let's look at Steiner path, Steiner tree, and domination problems and its variants in special graph classes. And in almost every slide, if you look at the footnote, you see a relevant research article. You may please Google it later to get to know more about the problem and the results I've been talking about. Fine. So that's all. Let me brief you about the opportunities available at our institute. And we have 3 programs, BTech, MTech, and PhD. And for MSc students or MPhil students, you can register for PhD in mathematics department, and you can do research in your favorite area in mathematics. There will be a department test followed by an interview. Please look at our institute website for more details. You will also get to see the previous questions and how do we assess you as part of interview and so on. You also find web pages of PhD scholars. You can contact them by email to get to know more about the program. And it's fully funded by Government of India. So you will be paid 31,000 per month for first 2 years and 35,000 per month for next 3 years. It's a 5-year program, and you get full funding from Government of India. Apart from that, you can also collaborate with us through internship. Suppose you are interested in doing summer internship in graph theory, you can contact me or some other professor, and we will give you a specific problem to work on. You can work with us for say 3 months. Or you are a faculty and you want to collaborate with us, at any time you are welcome to contact us, and please look at our website and feel free to contact us at any point in time. My email ID is my name Sadagopan at this website IITDM.ac.in. So it's exactly 10:30. So I'll stop. I'll spend another 5 minutes in case you have any questions or some clarity concern. I'm happy to take up. Or you want me to highlight some specific results in some graph theoretic area? If I know, I'll certainly highlight. Yeah.
Sir,
Yeah, please.
am I audible, sir?
Yes, you are.
Sir, is this we know that Hamiltonian property is NP complete. You have relaxed the graph by choosing the K1, 3, K1, 4 free graphs.
Correct.
Is this the only way to relax the NP completeness of Hamiltonicity?
No. Good question. We have taken one direction. So by
Okay.
looking at K13, K14 free and so on. So you can also bring the convexity. That's what I mentioned. So what you can do is you arrange the vertices in click side in one fashion and ask what is the complexity of Hamiltonicity in say this convex split graphs. Is it still NP complete or is it poly? This is one another direction. It is open. You can explore. You can also say you look at vertices in click side. They have neighbors on I. You say they can have at most say 10 neighbors, 5 neighbors. You restrict your degree, and you restrict your degree on either direction, I side as well as click side, and study a special graph. So basically, you can generate many special graphs and look at the complexity of Hamiltonicity. Good
Okay,
question.
thank you, sir.
Yes, so
Thank
we
you,
have
sir.
taken one direction. There are many other directions.
Okay, thank you, sir.
Welcome. Any other question?
Participants, you can post your questions in the chat box, so sir will clarify your questions. Sir, I think there is no questions from the audience. Shall I move to the next, sir?
Yeah.
Respected professors, distinguished research person, and the participants. On behalf of First Das Vaishnav College, with entire fraternity, I feel immense pleasure to take this opportunity to propose a vote of thanks to our resource person, Dr. N. Sadagopan, Assistant Professor and Head, Department of Computer Science Engineering, IIIT, Design of Manufacturing, Kanchipuram. Sir, we are thankful to you for sharing your expertise views with us, and it was a worthwhile experience to listen to you. I thank once again for providing us such an informative lecture and extremely relevant address in the contemporary mathematics and applications. Thank you, sir. I would further extend a hearty thanks to our Professor Dr. R. Venkatramanan, Head PG and Research Department, Dwarka Das Govardhan Das Vaishnav College, for always encouraging us and providing opportunities to organize such events. Once again, I thank you all for being with us. Have a wonderful day again. Thank you.
So thank you all. I thank Professor Venkatramanan and the entire team. Participants, if you have any clarifications, doubts, feel free to email me at any time. So thank you all.
Dear participants, the next session will start by 10:45 a.m. Thank you.
Good morning, sir. Am I audible? Good morning, Pankaj, sir. Am I audible?
Yeah.
Sir, I welcome you, sir. Sir, please
Thank
check.
you, sir.
You have a. You can share your screen or etc.
Okay, just let me check.
Yeah, thank you.
Is it visible?
Yeah.
Venkatraman, sir?
Yes, sir. Yes, sir.
Okay. So let me start. Hello.
Yeah, one second, sir. 1 second. Sir, we will start our session at 10:45.
10:45.
Yeah.
Okay. Okay. So who are the audience? Would you like to brief? So accordingly, I will plan. Nobody is here.
Sir, our audience are heterogeneous audience, sir, who are mostly from postgraduate department and research, sir, but few are
Okay.
from undergraduation too, sir.
Okay. Because accordingly, I will plan, na? Because the audience are is faculty members, then otherwise students members. So accordingly, the lecture will be
Yes, sir.
designed.
Faculties are also participating in this.
Okay, that's good.
Yes, sir.
That's good. So you are in the department. Where is Professor Venkatraman?
1 second, sir. I'll call.
Morning, sir.
Morning, sir. How are you?
Fine, sir.
See, I am here before time. I
am also here only, sir. We are in the auditorium, sir. We are assembled in the auditorium.
Okay.
So PG students and some research scholars.
Okay.
And faculties. Nearly around 50 faculties are here.
That's good.
80 PG students are here.
Okay, that's good.
Yeah.
So because you informed me that 10:40 deadline, so I thought let me join before, otherwise deadline will expire. So 10:30 I joined. I think yes. 10:30.
Actually, the first session will finish by 10:30 only, sir. Already I informed you. So join by 10:35 or 10:40. That's all. So we'll
actually last 1 week I was badly engaged regarding that 75th anniversary conference of
I know,
National University of Trade and Economics. A lot of discussions and things are there. So successfully yesterday evening by 7:30 the event completed. A very successful event. More than 15 countries participants are there. Yeah.
So I know about that, sir. Already I informed you. Already I posted a message to you also.
Okay.
Right, sir. Right, sir.
So I think within 5 minutes we will start. So you may take rest because you are continuously busy.
No. Sir, shall we start, sir?
Yeah. I'm ready.
Yeah. So our technical team and the organizing committee will take over, sir. Just a minute.
Good morning to everyone. Good morning to everyone present here. So, Department of Mathematics, Dwarakadas Govardhan Das Vaishnav College, I coordinately welcome our resource person, Professor Pankaj Srivaths, who has been serving Professor in Department of Mathematics, Motilal Nehru National Institute of Technology, Priyanjar, for more than a couple of decades. Few of his research areas are fuzzy data analysis, designing and development of soft computing in intelligent system, which refers to medical diagnosis and tourism, Ramanujam's computational system, tensor analysis, etc. Over a period, he has been carrying out some responsibilities in which I like to mention few of those. Head Department of Mathematics, Motilal Nehru National Institution of Technology of Priyanjan, and Secretary in National Academy of Science, India, Allahabad chapter, and advisor body of Government of India, and President in National Children's Science Congress, Allahabad, advisor in the National Academy of Science, General Secretary in National Children's Science Congress, Allahabad, and he is also been in sports too, athletic coordinator in Golden Jubilee Athletic Meet, and Deputy Dean of Student Affairs in Motilal Nehru National Institution of Technology. And in addition to of the professional membership, he has been membership over a few decades. The National Academy of Science India, Society of Special Functions and their applications, the Indian Academy of Mathematics, Indian Society of History of Mathematics, Indian Society of Mathematics and Mathematical Science, Indian Society of Fuzzy Structures, Cryptography Research Society of India, Indian Mathematical Society, etc. With the few wonderful words, I would like to invite our Professor Pankaj Srivatsa to present his wonderful lectures in the topic of mathematical modeling, information age. Thank you, sir. I welcome you, sir. I hand over to you, Professor. Can you take over, sir?
Thanks, Damodaran, for introducing me.
Myself, sir, thank you.
So let me share the screen that I.
Yes, sir, it's visible, sir.
Yes.
Now it's at present, sir. You can continue.
Yes, my screen is visible to each and everyone.
One second, sir. I want to give a small instruction. This is a small instruction to participants. The questionnaire session will be end of the lecture. So if you have any questionnaire sessions, you can even switch on your camera and mic, and you can put it in, or else you can put it in the chat box. Thank you. Continue, sir. Thank you.
Okay. Should I start?
Yeah, yes, sir.
Okay. Thank you. So the title of the talk is Mathematical Modeling Information Age. Actually, it is a very broad scenario because the students concerned with the undergraduate course and postgraduate course, even the young faculty members, those who are very much interested to see the application area of the mathematics, because this is a major query of each and every student of mathematics. Even then, those who are not associated with mathematics, they are also very much interested to know about the applications. And most of the time, we mathematicians focus on theoretical inputs without any applications. If any applications are there, that is only vague idea. That in aeroplane or somewhere else, this is utilized. Or in cryptography, it is utilized. But or in computer science or in the engineering science. So they simply just give a clue, but actually they are not at the user end. And that's why they are unable, just on the basis of the written document they used to code. Sometimes we used to evaluate a lot of PhD theses. And once the section concerned with the future scope of the research work, so that moment the author who has established a very good number of theorems and lemmas and results usually refer that this topic is very much useful in the engineering, very much useful in the medical science, very much useful in the software industry. Even then, he has not used a single word in the thesis about these contents. So that is a major gap at the user end, at the establishment end. Okay, mathematics is basically associated with the structural part, with the structural theme. Suppose if you are going to design a building and you have the idea of the structure, but you have no idea of the application part of that. So that moment, definitely that building will not be in a safer mode, because the tools and contents that you have utilized, that has nothing to do with the building construction. So that's why here, especially in mathematics, you will have to be very choosy. You will have to select, analyze the tools as you have been introduced by your faculty members, especially to be aware its application part, especially to be aware about the visualization part. If you have a visualization, definitely interest will be there. If no visualization is there, only a theoretical is there, alpha is replaced by alpha 1 or alpha is replaced by alpha plus epsilon, and putting a bogus condition that epsilon tending to 0. So this kind of bogus condition, if you put and establish a so-called new result, that has nothing to do, because it is simply a kind of manipulation or adjustment. In most of the theoretical research, it has been noticed that only manipulation in the results are being made. Interesting part will be that if you rather manipulating, you expose that result in the real scenario. As nowadays, the information age, it is not an information age I can quote, this is an information era. Under this information era, everything is based in terms of a data. Everything, either you are visiting Facebook, either you are visiting Twitter or Instagram or WhatsApp or Line or Viber or number of other social media network, everywhere you are creating knowingly, unknowingly a huge amount of data, and that data is directly concerned with your liking. That data is directly concerned with the business analytics. That data is directly concerned with the marketing analytics. That data is directly concerned with the advertisement promotional schemes. Under this information age, so how mathematics we can exploit? That's why the scenario that I shared just now, the data that is knowingly, unknowingly being developed by your end by making use of your respective social media network.
Kindly,
okay.
Sorry to interrupt you, sir. Sir, are you switching your slides, sir?
No, not. I'm switching it. Slide will stand still. Don't worry. Whenever I want to change, I will change.
Actually, it's not moving, so that's why we on.
No. Don't worry. It happens with me. Sometimes the slides, especially during the introduction part, doesn't change. It will change in due course of time. Have patience, please.
Yes, sir.
So, students, especially of this age, PG students, especially of this age, are research scholars as well as the faculty members, are very well aware about the data science. Nowadays, it is a very popular term. And due to this popularity, each and everyone is being attracted towards it. But the question is, how we mathematicians may jump in this domain. The word data analytics gives a clue that there is certain kind of analysis. What kind of analysis? How we may associate whatever literature we have, how that literature is helpful for the young mathematician, that they may be attracted towards. Rather than this, they are fascinated by the respective softwares. The software such as your Python means the programming. The tools like Jiffy software for the sentimental analytics that is generally used, are data visualization based softwares. So this is the data and this is the kind of visualization. So it is just like that, that cement is there and building is visualized. Means data is here, analysis part is concerned with the medical analytics or marketing analytics or advertisement analytics or overall in business analytics. How we'll club it, how we'll connect it. Or only software end is there. Usually you have heard that mathematics is a queen of science. You heard it, but never saw it. Because most of the time you are directly concerned with theorem and proof. Nothing else. Because after proof, application part missing. So that's why there is no connection with the visualization part. In 90% mathematical domain, it happens. So today I'm going to share with all of you the modeling scenario under the information age. I have given a clue that in this information age, the machine that all of you are using, either it is your mobile phone or the respective social media that you are operating, how it is helpful, how it is useful once you are engaged in the modeling domain. Modeling is a broad term. Nowadays, everything is concerned as a system. Design and development of a system, and system based on your mathematical operations. So as all of you are very much worried that the slide is not changing. It usually happens with me more than hours and hours. I used to give the introduction part just for the sake of the visualization part of your imaginatory skill. If you are able to see that, if you are able to visualize that, so definitely you will be the good user to handle the respective softwares. For example, data science is not a new, it's an ancient, since ancient period it is functioning. Nowadays, due to Microsoft and Google and other things, lot of companies are there, they are analyzing. Just for example, I'm sharing trillions and trillions of stars in the sky, right? But our saints, ancient saints, detected certain stars, connected them, and connected with the human body. Connected with the human body. That these are the stars, their color, their features, their behavior, everything is involved in the body system of the human being. And out of that, a number of stars have been designed in a certain shape. In astrological aspect, we call it as a rashis. And they developed some figures through their visualization skill, through their connection, because the previous lecture, just you have heard that is connected with a node and edges, means a kind of graph, a kind of picture was there. So this kind of graphical sketches or the figures or the design was imagined, visualized by our ancient saint, and they connected with the human body, and some of them analyzed that through the medical part. But how the human body will behave, and some of them associated these stars and their features through a certain figure under the name of rashis, the psychological approach of the human being. And some of them analyzed the skill in analytics and exposed the forthcoming events that will happen in their lives. So this data analytics is not a new domain. It already existed in our literatures. As I am also using since last 20 years, the advanced part of the data analytics, that is fuzzy analytics. But that moment in 2000 onwards, 2000, nobody was using the word data science. Nobody was using that. So that moment we are calling it as a analysis or model building, something like that. So let me share one by one the issue that is concerned that I am going to handle. I have given a clue that our ancient rishis and saints, they have connected these stars, and these stars have been directly connected with the human body and the human body and its function on the basis of the medical background. I'm not going to discuss here astrology. I'm not going to discuss here astrological analysis, but believe that is a level of excellence, especially in model building concerned with the information age, concerned with your forthcoming events. 100% it is true under the case of medical. See the behavior of each and every star and see the color. For example, little bit out of the context I am going here. The color of the moon and the color of your cough, that is connected with the functioning of lungs, exactly same. Exactly same. A person suffered from the jaundice, the color of the human body and the color of the Jupiter exactly same. So a lot of issues are there. So in somewhere, sometime, next time, whenever I will be with all of you, so that moment I will analyze and I will share with you that how this mathematics can be utilized regarding the model building concerned with the information. So remember, this information age, it is not now, it is since ancient period. Ability, capability due to the machines or due to the human visualization, it have been perceived, it have been visualized, it have been developed in the format of that. Here, my dear students and faculty members, I'm just giving an exposure that how you can develop a diagnostic machine, that diagnostic machine concerned with the human body, especially concerned with the blood sugar level. Remember, a machine or a model is not a unique. A machine or a model, not necessarily a ultimate one. Every time, every moment, upgradations are going on. Upgradations or the next generation of the machine are designed with the beauty of the mathematical tools. In the beginning, you may not be aware about the real beauties of the tool. In the beginning, you may utilize certain tools that you know, but after certain expertise, you may explore other tools as well. And with the help of that, you can develop something new. Or you may design a new machine or a new model that provides much better information than the previous one. That's why I'm saying that the next generation of the machine comes in picture. You know, in between the 2 points, infinitive numbers exist. Infinite, the 2 numbers, infinite number exists. So the same way, there are infinite number of tools are there, and you are the person. If you are interested to be at user end, you yourself may realize that which tool is much better than that. So dear students and faculty members, in this talk, I'm going to share that how you can design an intelligent system, how you can design a system, or how you can design a diagnostic system concerned with the blood sugar. If you have good quality, definitely other end machine can be designed. Other end systems may be designed concerned with your cardiac issues, concerned with your liver functioning, concerned with your kidney functioning. That depends upon your interest. Generally, mathematicians are far away from medical related issues. But medical is an open domain where excellent number of work can be carried out with your own knowledge skill. So my suggestion to all of you, enjoy the modeling with mathematical tools in the field of medical science. Okay, have a glimpse of this. Lot of things I will share that you may read through these slides. I'm not going to share each and everything through the slides because the slides are for you, not for me. So it's your duty to go through the content that is mentioned in the slide. In general, I will give you a clue about that because each and every family of this continent, especially the southern means the southeastern part of this Asian continent, is highly affected by the sugar related or blood sugar related issues. Knowingly, unknowingly, due to their poor lifestyle, due to their heredity character, and due to the side effects of certain medicines, it happens. Blood sugar going up or going down, it is a kind of similar phenomena associated with your other issues of the body like blood pressure, like other medical parameters. Each and every family is highly affected by this disorder. Each and every family, due to their workload, due to their interest, and due to their approach, in due course of time, comes under the grip of this medical disorder. The purpose of this talk is how, being a mathematician, you can develop a diagnostic machine, and that diagnostic machine, how much will be helpful, will be useful to the society. So your work, whatever you are going to develop, how much it is useful and concerned with the society purpose. It is not necessary that every work may be used for only research purpose, not for the user, not only for the Scopus end publication, not only for the SCI end publication. Publication is a different story. Publication of an article is a different story. But if your content is good, if your application part is good, so definitely the day will come, these journals will accept your article. In the beginning of the publication of such articles that we design, we faced a lot of trouble. That moments on the editor's end, we used to receive a complaint or we received a letter that we don't have an expert who is having equal expertise in mathematics, in medical science and system science. So therefore, we are unable to process it. It is I am talking about during the phase of 2000 onwards. Later on, step by step came, but sometimes still we face issue because publication of a pure article is easy rather than publication of a multi-domain, multidisciplinary domain article. Because in multidisciplinary domain article, the person who is going to review your article not necessarily be of your same age. His visualization will be different. So as Professor Venkatraman has asked me to deliver a talk concerned with the mathematical modeling and information age. So dear colleague, I am just going to give a clue that we have designed. It is a very old model. Lot of generations we have developed. But I was having a view that most probably the students will be there. So it is better to give a clue about it. This article published way back. And lot of generations have been, new issues have been developed and designed. So I think in the previous meeting with the Professor Venkatraman during the phase of the course curricular designing, that moment I suggested to refer the contents issued related with the fuzzy theory. So dear colleague, I would like to utilize the tool are concerned with the fuzzy theory. Before that, have a look on the issues that is concerned. So that the blood pressure, how it happens, I have already shared with you that it is due to the poor life state. It is due to the your family history, hereditary characters, your tension means if you are in a depression mode or something like that, lot of issues are concerned that happens automatically in your body system. So if you don't care about it, so definitely the drawbacks are there. The drawbacks are there that they are likely to be heart diseases, blindness, kidney failure, and other issues. And it is believed that this South Asian region of the Asian content is the capital of the world regarding with the sugar related issues. So I'm not going to share all these story concerned with the issues related with this, because diabetes doesn't need any formal introduction, but the persons or the students, those who are aware about the diabetes must be very well clear that the negative effect of the diabetes is a lot. It almost makes a system failure inside the body system. A lot of physical exercises were suggested, and that is based on the regular practice. Now the question is that, okay, all these physical exercises are effective, and all these physical exercises, if you just go through the Vedic, the asanas, so all these asanas are concerned with a picture, and that picture is concerned with the nature, and that regular practice of that particular picture in that particular asana gives a positive impact on your body system. Here I would like to ask one question with my students, with my colleagues, that what is their clue about linear system and non-linear system? Or whether they are only aware about the linear algebra and linear differential equation, whether they are aware about the linear system or a non-linear system, not a mathematical part, the application part, how you can guess that the given system is a linear system or given system is a non-linear system, or merely aware about the linear differential equation or a non-linear differential equation. Do you have you read in your text? Because in your text only these two words are there: the linear algebra, linear independence, linear dependence, linear equations, linear differential equations, but I am concerned with the linear system and non-linear system. Are you aware about? Okay. You may search the definition, but I am just giving a clue about it. That is, suppose if you take anything and break it, reassemble it. If you exactly reassemble the content after the breaking part, means the breaking process is the first. You reassembled it exactly in the same strength and in the same form, the same function. Definitely that system is a linear. But if it is exactly not the same strength, exactly not the same functioning, exactly not the same procedure, so definitely it is a non-linear. Even the two friends are there. Once the friendship comes under the suspicion, means it comes to a break. After negotiation and adjustment, if they again join as a friend, will the system will be linear or a non-linear? Will the friendship will be exactly the same as it was before breaking process? Definitely not, because a kind of suspicion will appear. Even in a mathematical principle, all of you have been taught by your respective faculties that once you have a set and you determine its complement and then you take its union, so that moment you suggest that this is the same set. Same thing that I'm talking about here, that if you take a content, break it, and then reassemble it, As per the set theoretic information, it will be exactly same, but not it is. That is verified by other tools. So dear colleague, I'm just, because the time is the limit, lot of explanations are required, especially modeling is not an easy game. Modeling means you will have to visualize each and every aspect. You will have to take care about. That's why I open the Pandora of linear system and non-linear system. Means what kind of issue you are going to handle. So medical system, that is medical analytics, that I'm going to introduce you. Design and development of a diagnostic system, that I'm going to introduce you. That's why all these basic informations are essential. So I would like to hear brief that the system that I'm going to share with you, this system will provide the actual status of each and every patient who is interested to know the current phase of his disease, his or her. What is the current phase of the respective disease, whether it is diabetes, or it is related with the cardiac issue, or it is related with the eye related issues or dental issues, whatever may be. Means the system that you will design, that will give you a situation, that will give you a current status of your medical fitness, whatever be the issue that you are examining. So here in this system, we are examining the diabetes related status of a physical of a human being. So let's have a look that as a basic information, generally the respective tests are referred, that is the fasting blood sugar, the postprandial blood sugar, random blood sugar, HbA1c, or oral glucose, means OGTT. These are the general tests. With the help of that, you yourself can assess that what is the current status. But every moment you cannot go for all these things, because the phenomena that occurs in our body system is a nature based. You cannot manipulate it. You cannot change it. It automatically, ups and downs are happening inside the body system. If all of you are aware that if somebody has tried to control on their own, he failed. And if you have gone through the details of the Michael Jackson who was having a plan of a life phase of 150 years. So that's why a number of medical experts team was always with, and every day they monitor what is going up, what is going down, and something that is going down, they are injecting the injections and trying to maintain the standard figure. And what happened? A severe cardiac arrest happened, and he collapsed at the age of 50. So that's why every moment you cannot control something that happens inside the body system. Not only the medicated part, it happens due to your thinking process, due to the surroundings where you are living. Lot of infinite number of factors are influencing this body system. Infinite number of approaches are there to control the phenomena of medical parameters inside the body system. So remember, artificially you cannot. So that's why here just I am giving a clue that how you yourself can design and what are the essential tests that we use to do it. As part of because it is an elementary model that I'm sharing with all of you, the three risk factors that we are going to take here, the risk factors that is I'm sharing here, that is age. This is one of the issue. Obesity is another issue. The fasting blood sugar is one of the issue. Postprandial blood sugar is one of the issue. HbA1c is one of the issue. In my conversation, I have given a clue that a kind of uncertainty exists, and that uncertainty you cannot control. So what kind of tool is required to handle this uncertainty? Uncertainty due to information. Uncertainty concerned with the information. And that information that happens due to the imprecise data, imprecise idea. If you have no clear-cut idea and only imprecise ideas are there, so then how you can model, how you can develop system? So that's why a different kind of mathematical tool is required. One example I would like to share it, that during the phase of 1926, almost 100 years ago, a renowned physician from Europe, his name was Ludwig Fleck. He shared his observation that in almost every cases, it is his word, not mine, that almost all physicians are unable to explain that on what basis they have made a decision regarding a certain disease on the basis of certain 1,000 number of symptoms. What was the criteria? What was the scientific modeling? On what basis they analyzed that this person is suffering from this disease? And that moment, he quoted that we need a support of mathematicians. We need a support of mathematicians to provide us a tool that may be helpful, especially for overcoming such kind of uncertainty or ambiguity or complexity that usually happens related with the medical diagnosis process. The medical diagnosis is the most complicated issue. But that moment, all mathematicians were very much engaged in the field of summability. That is the phase of summability, where you can go through the 100 years old research work. Most of the mathematicians were very much engaged in the series related issues. Even then, Ramanujan was that moment very much engaged with the series, hypergeometric series, basic hypergeometric series, bilateral hypergeometric series. All these things they were doing. They are not at all concerned with the support that was required, that was asked by the Ludwig Fleck. Maybe one of the person, Jade, L.A. Jade, have some kind of visualization, and that's why he developed a fuzzy tool or a fuzzy set that was introduced in 1965. And this fuzzy set was directly concerned with the uncertainty, or it is directly concerned with the imprecise informations, or the set that is directly concerned with the uncertainty based tools. So dear students, a lot of time I have taken regarding merely the introduction part of the modeling concerned with the information age. So I will go rather fast because I have only 10 minutes. So let's have a look in 10 minutes, because most of the time I have tried to explain, to give a visualization. So dear students, certain inputs, because if you want to develop a system, an input is required and output is required. So what will be our input? This is the input is the concerned person's age. And age is classified in 5 layers. Layers, as you know, in numerical analysis, the finer the division is in between the 2 points, the finer the result will be. So finer the number of layers concerned with the human age, definitely the result will be a super quality. So what is the age? Age has been classified in various layers, and these layers have been mathematically translated. Similarly, the respective graphical sketches will be designed. The fasting blood sugar, the various layers of the fasting blood sugars is here, and their respective mathematical translation is here in the form of nonlinear functions. All right, so I'm not going in detail about all these things. So just I'm giving a clue that the nonlinear functions are also are being used here. So, and their graphical sketches are there. The concern with the postprandial blood sugar, this is mathematically translated in a various number of layers, and all these layers have been translated with the help of nonlinear tools and their respective graphical sketches. Physical exercise, what kind of physical exercise you used to do, and how we can mathematically translate it of that particular event. So the 5 layers have been designed based on the minutes feature, 10 minutes, 20 minutes, 30 minutes, or something like that. Its mathematical translation are here. Similarly, the output variables, what will be on the basis of these input variables? You may increase the number of, because a human body is not handled by 3 or 4 parameters. as all of you are there at the very elementary phase. So that's why it is essentially required to motivate you to come and join this domain. So just start the game with a very limited number of inputs, and on the basis of that, what kind of output you require, accordingly try to develop a system. So what are the outputs are there? The outputs is that we want to test whether the person is a normal one, or the person is a pre-diabetic one, or the person is a type 1 type of disease, or type 2 type of diabetes. So once all these mathematical translations you have made, because respective either it is age, or it is blood sugar, or it is postprandial blood sugar, or it is your physical exercise, or concerned with your hyper blood other issues that is being translated here. So you can combine it. For example, I'm sharing that once you visit a medical expert, so that moment the medical experts used to write whatever you share, and then he tried to connect all these components that you have shared with the help of that, and with the help of that he tried to analyze or diagnose that what may be the most possible disease that may be occurring with, that may be associated with you. So these are means the inputs that you have shared. These inputs on the basis of number of layers will be designed. So it may be in lakhs, it may be in billion or trillion, depends upon your system, depends upon your computing machine. You may handle all these data that will be developed. So here, for example, we have taken only 625 slides on the basis of this input, and this on the basis of the number of outputs. So because you will have to compute all these, because their respective mathematical translations are there, accordingly these strings will be numerically quantified. Once these strings that is observed on the basis of imprecise criteria now being quantified in between 0 to 1, then you may perform the rest of the mathematical operations. So here on the basis of this, then we try to involve a medical expert, and that medical expert will suggest you on the basis of these strings. Means suppose these 625 strings will be shared before a medical expert. Mathematically, we have already computed the numerical quantification of that particular part, but we are very much interested to know the view of a medical expert. So that's why all these strings will be placed before a group of doctor or a respective expert, and with a request to assign a number, and that number lie between 0 and 1 regarding the medical condition of the respective patient whose data has been already shared in the form of a string. So, and this way we develop a utility matrix, and that matrix contains the number between 0 to 100. The patient, if he is allocating the marks nearby 100, means the patient is in danger domain. The patient whose mark has been allocated nearby 0, it means he is in a much safer domain. So remember on what criteria we generate this utility matrix. On the basis of this, then we try to calculate the contents associated with the utility set. We try to maximize the utility set, and then we optimize the utility set, and on the basis of that, the rest of the diagnosis part is carried out, or rest of the medical analytics part is carried out, or in a simple set, the simple frame, the data analytics part will be carried out. So I have just given the clue that what are the respective contents are there. See here, once you have designed a system on the basis of the so-called input and output parameters, input variables and output variables, on the basis of that, let us have a look of the real life data of a patient. So here, have a look of a real life data of a patient. This is a gentleman whose age is 35 years, whose fasting blood sugar is 76, whose postprandial blood sugar is 221, and whose physical exercise phase is 32 minutes. So the respective fuzzy sets will be developed on the basis of the theme that I suggested in the beginning, where we are mathematically translated on these certain input variables. And on the basis of that, we develop a fuzzy set of the respective fuzzy string, the linguistic strings about which I shared, that we compute it on the basis of the mathematical translation. And then we develop the respective utility set, and these respective utility set on the basis of the respective calculations, right? Similarly, these utility sets are maximized And after maximizing, then we go for, because each and every medical data will be analyzed on the basis of the 4 outputs: the normal, the pre-diabetic, the type 1 and type 2. So each and every data will be analyzed on the 4 criteria, and these 4 criteria will be mathematically computed. Rest, then we go for the optimization of the utility set, and here on the basis of the optimization of the utility set, we will select the highest value. Highest value will decide that what are the parts. So out of the first optimization part of the fuzzy utility set, that is associated with the normal feature. So the normal feature number is 0.4771. The pre-diabetic content, it is associated with the second utility set, and maximizing second utility set and optimizing second utility set. From there we collected this data. Similarly for this type 2 or type 1, and similarly for type 2. Out of these output, the highest ever figure, whatever is available, that will give a clear indication that the patient is infected by this. So here you may check that the highest figure is concerned with, that is what, this is 0.5208. So therefore, what is the picture is there? The picture is the data, the data, medical data that has been provided, or the laboratory test that has been provided. On the basis of that, the system that we have designed, that has calculated and that has provided a data, and on the basis of that data, it is clear that this person is suffering from type 2 diabetes. Similarly, if you check the another computation concerned with the another real life data of a person whose age is 33 years, whose fasting blood sugar is 139, PPBS is 148, physical exercise is 15 minutes. The same process is adopted, the entire analytics operations are carried out with the support of the machine that we have built up, and each and every output will be analyzed on this data. So therefore, what we have obtained, we obtained that here all these output have been computed, and here we notice that the highest ever data is 0.8123. So this gives a clue that this patient is directly concerned with the type 1 diabetes. Similarly, the case 3 you can check. The data is here of a senior person whose fasting blood sugar is this, postprandial blood sugar is this, physical exercise is very less, only 10 minutes. So the rest of the process is carried out, and here the calculation indicate that the 4 output that has been calculated with the help of this diagnostic system provides the data for normal, provides the data for pre-diabetic, provides the data for type 1, and provides the data for type 2, and here it indicates 0.9025. This indicates this person is affected by type 2 diabetes. So graphical sketches that you can design. Similarly, the another physical data of a patient may be considered, and maybe go through the rigorous mathematical process. Not rigorous, because once you develop a machine and the machine is built up, and then easily it can be carried out. And here that confirms that this person is having a chances of further cross investigation. So this is a glimpse of a machine with the help of a mathematical tool, especially with the help of fuzzy tool. The fuzzy tool is directly concerned with the uncertainty related with the information. Remember, we are talking about the mathematical modeling approach concerned with the information age. And information is not always a final. Information is always ambiguous. Information is always imprecise. A complete information you can't, you will always in an imprecise mode. So definitely a certain kind of tool that is handling, that is capable enough to capture all these ambiguity that you can utilize. You cannot handle this issue with the help of a simple CRISP set or simple pure mathematical tool. You will have to go through the tools that is competent enough to capturing the information. So therefore, the lot of investigations we have carried out. For example, I'm sharing the 6 cases here. In all these cases, the issue is directly concerned with the diagnosis part. So remember, if you have a very good interest in medical science, and if you have a very good knowledge of a mathematical tool, or a very good knowledge of mathematical tool to exploit in the real life scenario. So definitely the visualization will come. You just go through the mathematical tools and try to visualize the approach, that whether it is matching with the behavior of the disease or not. If it is matching with the behavior of the disease, then this tool is absolutely right. Due to the shortage of time, I was not able to explain how the function is selected, how the function is, because I have given a clue here that a system is linear or non-linear. I have given a clue that on what criteria, but due to the lack of the time, I am unable to give the complete explanation that on what basis you yourself can select or choice, make a choice of election or selection of a respective tool. For example, I'm just giving a clue here. A triangle, a trapezoidal, and bell shape. These three figures are directly associated with all the happenings that is occurring in your body system. Now you yourself visualize whether this triangular shape or trapezoidal shape or bell-shaped shape matches with the behavior of the disease or behavior of the medical ups and downs, or medical with the all the medical parameters that is directly associated with this, right? So try to go through the figure that the respective function generates and try to go to the computational part with a vision that it will match with the diagnosis part. So it needs a lot of explanation, because as you know that making a film is a not easy job, because on a very short story you will have to develop a film of 3 hours. So a lot of factors are involved. The same way, designing a system means you must have a patience, you must have a good listening power, you must consult each and everyone irrespective of your ego, discuss with each and everyone. And you know that finally what comes, finally the mathematical tools comes in the driving seat and plays a major role. So listen everyone, have a patience to learn each and everything concerned with the respective topic that you are going to handle, and then utilize your mathematical skill whatever you have. Here I have just given a glimpse of a simple tool, that is a fuzzy tool. Lot of generation of fuzzies, a lot of new wing are there. With the help of that, you yourself can develop a very good number of diagnostic machines, and that will be very much capable enough to diagnose a patient, or even a patient may test his or her own data with the machine to judge what is the current situation. So thank you very much, because the time is already over. These are the concerns related with the reference of the papers that we have done in the previous. So thank you. If you have any query, please feel free to ask. Any query, please come forward. I am ready to give a reply.
Audience, any questions, please ask. Audience, any questions? Audience, please ask any questions. Okay, now I would like to take place of vote of thanks on this national conference on contemporary mathematics and applications. I want to express our hearty thanks to Professor Pankaj Srivastava for giving an excellent presentation topic focused on the design and development of a diagnosis of diabetes patient. Thank you very much, sir, for excellent presentation. Participant to fill the feedback form in the chat box. Thank you, sir.
Thank you. Welcome, ma'am.
Next section to start on 12 noon. Thank you, sir.
So should I leave?
Yes. Thank you, sir.
Okay, welcome, welcome. Convey my thanks to Professor Venkatraman.
Okay, sir.
Okay,
Thank you, sir.
okay, bye.
Welcome, ma'am. Ma'am, Dr. Asha K. Welcome, ma'am.
Good afternoon.
Good afternoon, ma'am. This is Damodar. You are now co-host, ma'am. Can you share your slides? Please check it.
1 second.
Okay, ma'am.
Is the screen visible?
Yes, ma'am. Ma'am, session starts at 12 p.m. ma'am. Can you please wait?
Sorry, I couldn't hear you. You're not audible.
Okay, ma'am. The session starts at 12 p.m. ma'am.
Okay.
Greetings to everyone. I extend my warm welcome to all of you. This session of National Conference on Contemporary Mathematics and Applications, organized by Postgraduate and Research Department of Mathematics, Dwargadas Govardhan Das Vaishnav College. The topic of this session is Neuro-Inspired Contemporary Computational Brain Intelligence for a Digital Transformation by eminent speaker Dr. Asha K, Assistant Professor, Department of Advanced Computing School of St. Joseph's Institute of Institute of Information Technology. It's my pleasure and honor to welcome the speaker to the conference. Dr. Asha, an envisioned academician and researcher working as an assistant professor in St. Joseph's College, Bengaluru. She obtained her PhD in computer science from Bharathiar University, Coimbatore in 2014. Dr. Asha worked in many organizations in India and abroad and have more than 15 years of experience in career. Her research interest includes sentiment analysis, computational machine intelligence, and brain-computer interface. She served as Center Coordinator and Research Advisor for British University Dubai campus, and was authorized guide for research scholars pursuing interdisciplinary research. She pursued her she published many international journals, book chapters, and research projects to her credit, holding membership under several professional bodies in India and abroad. With this note, I hand over this session to the resource person. Ma'am, you can continue.
Thank you, sir, for your detailed introduction. And I'm also glad to be a part of this national conference. I think we can start the session now.
Yes, ma'am, you can start now, ma'am. Now your screen is visible, ma'am.
1 second. Is the screen visible now?
Yes, ma'am. Your screen is visible.
Okay. So very good afternoon to all. Today we will talk about perception. Especially we and other animals perceive the world around us. And why is it necessary to combine together or bring together the computer science and neuroscience? This is not just understanding the concept of machine learning, but to understand our brains as well. The future has been promised by science fiction that in future, we will have a house that can understand us and autonomous cars, all the scenarios, computer can contribute a lot of ideas. It's just exactly equivalent like how a machine can perceive the world around us. But the key here is the perception. Without perception, we cannot take any decisions correctly, whether you are a machine or an animal. So how do we test this right now? I have a small test for you. See, everyone in the audience are having fantastic, capable sensory and auditory system. So if you want to test that? I have a test for you. What did you see over the screen? I didn't give you the clue that, or I didn't give you to focus your attention towards a particular area of the image. But I didn't give you a clue that it is an animal, or I didn't give you a specific information regarding that this is an animal and how does it respond. So to interpret the particular image in effective way. But for a computer system, even locating the image over the screen itself is a not trivial technical challenge. But as we all know very well, related with the machine learning research can perceive and understand the knowledge effectively. But the question here is this picture cute? This question gets the fundamental difference between machine learning and the actual intelligence. But we have a specific scenario over here in the real time. We train the computer system providing thousands upon thousand cute animal pics and thousands upon thousand less traditional cute animal pics to interpret the image. But that is not the way we perceive or we understand the concept of cute. We generally understand the concept of cute by unique unique number of individual experience and perceived context and natural instinct. In the machine learning scenario, this is considered to be the ground truth. But the greatest challenge of the machine learning algorithms are to program these algorithms and to deal with these particular ground truths. And the success of the particular algorithm depends on the result should be good, how good as you are. But this is not the end of the particular research you go. We can create an artificial intelligence system just like better than that, or making more advantageous or expecting more characteristics towards the direction and help the particular system to imagine too. So here, the motivation behind the work. Extraction of emotion from human authored text documents are generally referred with the term sentiment analysis. And at the initial stage, the resultant from the sentiment-oriented text was truly fascinating. And the data has been tested with multiple domains, and it has been concluded the fact that sentiment analysis is domain dependent. And there are few pitfalls related with some area. This is related with the irony and sarcasm of the particular text represented, types of negation, word ambiguity, multipolarity, sparsity, multilingual languages, emotion detection related with the languages, and subject detection from the languages are few pitfalls among these. And we identify that in these kinds of scenarios, sentiment analysis has misguided the judgment related with semantic orientation. So the current techniques existed in sentiment analysis couldn't deal with the problem that is known as inability to perform in different domains. And in case of performance, if you see, the accuracy was inadequate and incapable to deal with the complex sentences. These factors motivated us to narrow down the new potentials in sentiment analysis and to identify the reason behind sentiment orientation. Then we have taken a step towards that. Combining AI and cognition can solve this. So this is generally related with the identification of the brain activity can be measured in multiple scales as like human, non-human, mammals, and other animals. And we have filterized the style of language and compare it with the different groups and track these changes over a period of time. So this was a general activity once initially started with the combination related with AI and cognition was involved in. Then come up with bridging the gap between the potential causes or identification related with why the emotion which is expressed in a text, it's happening in a right way, and the general difference between the actual emotion. So bridging the gap between the potential causes that supports for extracting the emotion which is represented in a text and actual emotion can be identified by introducing some neuroimaging techniques that is referred as an electroencephalography, and this will be considered for the better sentiment analysis further. So if you check in the theoretical point of view, from the diagram you are able to understand that modern computational neuroscience hails in two traditions. One is neurophysiology and the other part is related with experimental psychology and computer science. So this neurophysiology deals with the quantitative branch of biology. So our concentration was not towards this direction. So we started analyzing the details related with experimental psychology and computer science for information processing. This is illustrated by artificial neural networks. And there are multiple number of multi-level tools as the form machine learning tools used for coding and decoding the neural signals, which is collected from brain. And these plays a major role in terms of brain-machine intelligence. Now, from the multisensory integration to decision-making leads to the development of neuromorphic computing devices. We'll look into it in detail. Have you noticed any time why words are become harder to remember as we get older? And women of reproductive age experiences different level of irritability and mood fluctuations. And apart from this, smoking and other risk factors are less decisive in relation to depressions. It completely depends upon the age, comparing with youths and the old age people. So from these factors, still focusing towards the direction that still be required a harder study or detailed study related with our brain signals to understand our emotions. How can we connect our brains to the technology? There are different methodologies which is available in real time. The first one is represented here, electroencephalography. Here, different electrodes will be placed on the brain to track the variations in brain signals. And the second one is related with the functional magnetic resonance imaging. These are depend upon a particular brain activity. What are the variations in blood flow that's happening can be traced on the basis of fMRI. And functional near-infrared spectroscopy. These are related with a specific brain activity. Is there any changes which is happening in the hemoglobin that can be traced on the basis of that? So throughout our research, we have selected the neuroimaging method, that is electroencephalography. This is considered to be a cost-effective method to identify or trace any kinds of real-time scenarios. The method is considered to be brain-computer interfaces. Brain-computer interfaces doesn't understand the mind completely. But if you are thinking in a certain way, these BCIs or brain-computer interfaces can detect the signal variations that is powered by the brain. And there are 3 different types of brain-computer interfaces which is available in real time. These are considered to be non-invasive method, semi-invasive method, and invasive methods. So the semi-invasive methods are something which is related with the devices that are inserted into the skull. So this is while listening the property of the particular BCI itself, we'll able to understand that these are little costlier effort if you wanted to make use of semi-invasive and invasive method. And the other one which is inserted directly into the human brain by critical surgery. So our concentration is not towards this direction, so that we have compelled to use non-invasive method that is considered to be the safest and low-cost device to capture the brain's signals and variations effectively. Now, what are the different tasks included in EEG-based emotion recognition? These are considered to be signal production, signal detection, signal processing, and signal transduction. So signal production can be done. The active signals can be produced on the basis of how stimuli are generated on the basis of that. And signal detection, it's an electrical brain activity and related with the signal processing. There are multiple number of noise generally tends to getting accumulated or tends to get accumulated. These kinds of signals will be collecting it. So avoiding the particular noise from these particular data, that's considered to be the signal processing. There are different kinds of methods which is existed. Generally, the different procedures like outlier removal and centering, bandpass, and all can be considered for these signal processing procedures. And signal transduction is related with converting non-electrical signal into electrical signal. So in such situation, I can put forward a good example. At the time of recording a brain signal activity into a specific time frequency variation, there are more chances of data or the recording which is associated with the grinding of tooth will be occurred. At the same time, eye blink or eye movements, that particular variations also can be included into the recording. So these are considered to be the noise related with the particular scenario. This can be removed or filtered out on the basis of these particular scenarios. So here we are generally using or decoding the embedded signals to understand the particular signal processing in a detailed way. Moving to the other one, it's related with the EEG-based emotion recognition. So what are the general procedures has to be taken care while we will be dealing with EEG-based emotion recognition? The first step is related with artifacts removal. So there are different kinds of artifacts which can be removed from the EEG signals that can be collected. Methods like principal component analysis and independent component analysis can be used for the removal of artifacts efficiently. And apart from that, collection of spectral features from EEG signals based on time frequency domain basis. So these spectral features, you can take care under the form of what are the different identification of epochs has been done. Epochs are nothing but these are the high level of ecstasy or emotions. This is considered to be the epochs. So which particular time duration or frequency domain this epochs comes under, these epochs identification and the selection of electrodes, how you are selecting the electrode and you are placing it to extract the signals. These are important. This ensures the quality of the feature selection. And multi-class classification strategy completely involved up with the different kinds of algorithm. It can be into the form of generative or discriminative classifiers can be used, regression algorithms, and different kinds of naive Bayesian classifiers also can be used, and linear classifiers also can be used in such situation where we will be taking care of different kinds of artificial neural networks, support vector machines, algorithms, and k-nearest neighbor algorithms, etc. There are multiple number of classification algorithms can be used in this particular scenario. Now, the importance of EEG or electroencephalography emotion classification. So there are two important things at the time of classification has to be taken care. One is the position of the electrodes we are fixing up to extract the particular signals, and the clinical grade EEG headset versus wearable low cost EEG headset. So the quality of the particular EEG headset we are using it and the electrode position, where have to be fixed this particular electrodes. This is also one of the major component, have to be thoroughly checked at the time of emotion classification. There is a standardized electrode placement scheme, which is represented over the screen, where you can see from the diagram, there are frontal lobe, central lobe, and temporal lobes, parietal lobe, and occipital lobe. So these are the general areas where we will be placing the electrodes on the skull. So this is considered to be one of the major criteria where you are retrieving the signals. And the common EEG headset is used in real time. This is another point where Emotive Epoch, OpenBCI, and NeuroSky devices, BioSemi Active 2, these are the general real-time available common EEG headsets. You can check in some e-commerce sites through that. It's cost less than 20,000. You will be able to get this machines through this e-commerce site is also available for the same. So any OpenBCI is also one of the good EEG headset which is using to work with or retrieving the brain signals very effectively. And how the stimulus can be performed it. The emotions in brain are associated with producing the stimuli. So stimuli are generated on the basis of the different events that are represented here: virtual reality system review, music, music plus picture, music videos, video clips, and book reading. So these are the general stimuli originating events can be considered. So apart from this, our concentration was completely towards the direction of book reading. So while reading the book and the content of the book, how the brain signal variations which is happening in a particular human. So this was the base study we have started working on with. And emotion detection for textual big data. Why is it required? During the pandemic, in COVID pandemic, Max Planck University has done the research related with the emotion detection for textual big data in multiple domains. And they have published this particular article related with the general usage of emotion extraction using brain-computer interfaces in textual data domain. This has been reported that the mental health itself, it's reporting 60% of the usage associated with the textual big data. And remaining 20%, it's related with the defense. They have highly recommended for the usage and recommendation towards the emotion detection using textual data, and remaining 10% for the educational industry, because all the classes which are happening through online, so it is necessary for detecting the emotion related with the textual content. And in case of medical department itself has been put it forward, stating another 10% will be having the role towards, it's a high usage related with handling emotion detection in terms of textual data. What are the different challenges which is existed? So related with the human being at the resting stage, what are the heart rate variability, and is the BCI performance are getting affected with resting state heart rate variability? This will be a major challenge in today's real-time industry, those who are working with neurological challenges. So this has been looked forward into the direction of psychophysiological and neurological challenge. And there are different kinds of technical challenges also has been reported. These are event-related potentials. Event-related potentials indicates this will be stimulated on the basis of watching different events. Steady state visual evoke potential. So this has been resulted on the basis of the visual scenario or visual scene you are experiencing it. And it is related with the auditory evoked potential. So this has been generated on the basis of different kinds of response to the auditory system or auditory potential which you are experiencing it. And a steady state somatosensory evoke potential. These are repetitive method of events which has been tracked into the brain. So these are generally referred into the form of somatosensory evoke potential and imagery. So this will be completely depending upon the visuals you are experiencing it on the basis of the visualized trajectories. What will be the different kinds of brain variation which is happening in? These are the other technological challenges. You can put it forward in the real-time scenario. Now, the following terms are considered to be the general basic building blocks related with neuromorphic computing devices. So these are considered to be the elementary things which has been promoted towards the direction of neuromorphic computing devices. What are neuromorphic computing devices? Why do we getting so much boom in the real-time industry related with the neuromorphic computing? So this particular paradigm, it's considered to be the new era where we can mimic the functionality of the neural system in brain. So this is having the potential to mimic the functionality of neural system in brain. Now we are already working out with artificial intelligence, the concept of artificial intelligence, where we will make the system to exactly to work like human, think like human. So why does it require a neuromorphic computing? Actually, what does it mean? And what are the general activities which comes under if you will be taking care of this neuromorphic computing devices? So the generation of neuromorphic computing devices, I have already told you, this is integration of multisensory stimulus and leads to the decision making. From these particular multisensory elements or stimulus to decision making will lead to the development of neuromorphic computing devices. So there are different advantages. Once we work it out with artificial intelligence, we have come to know that is, it can work as efficiently as the human brain without acquiring large room to place the software. So many times, if you're working with these kinds of artificial intelligence supported technology, you might be knowing that we have multiple times we have come across that the space issue, the software which is using that is associated with the artificial intelligence need to get stored in large number of spaces required. So these accumulating the large space related with the system can be overcome by using this particular computing paradigm. Not only that, this is related with the neuromorphic computing machines are looking forward for low power consuming conception. So these are the general points to put it forward while working up with neuromorphic computing devices. So these are the two particular contexts we will be working towards. So compare it up with the artificial intelligence, you can say that neuromorphic computing will be acting up into the form of the future of artificial intelligence. What are the disadvantages we have faced while working the artificial intelligence technology can be overcome by using neuromorphic computing devices. Now, what are the emerging technologies in this term? The emerging technologies are intelligent wearable helmet for early stroke detection in patients based on artificial neural signal analysis. We are currently working with this particular scenario and aspect where we are assuming that over 90% of the results are truly approachable by the industry also. So early stroke detection related with the patients based on artificial neural signal analysis. And semantic characterization analysis related with the sleep disorder analysis is also another area. So those who are currently working with the real-time industry in BPO sectors, those who are working with the night shift and other UK and US shift, those who are involved in. So whether they will be their characterization analysis related with the direction of whether the behavior will be similar to depressive stage or how much percentage of depressive characters they are showing it. So whether a particular individual characteristics, if you will take care of it, this will be the percentage of accuracy towards showing the depressive characters is all are the general area we will be taking care of in this particular section. And understanding the effects of menstrual cycle on training and performance of women's. So how does the training and performance will be variated in women's? That is also another category. And design of robotic wheelchair. This is a common general application which can be implemented on the basis of brain-computer interfaces. And what are the different kinds of mathematical modeling can be supported while implementing these scenarios? So here, there are different methodologies can be adapted for data analysis in neuroscience by correlation, convolution, spectral analysis, principal component analysis, and simple differential equation and linear algebra. So these are the general areas. The data analysis, it's happening in detail way. So this will be generally building the bridge between how the interdisciplinary work related with computer science, neuroscience, and mathematics. The major role of mathematics in modeling will make a major role at the time of data analysis and implementation in the real-time era. Now, from here onwards, there are few slides I have put it to help you out for those who are generally interested in working out with this particular area for neuromorphic computing. So here, generally, we are creating the devices to work with or to extract the variations which is generally happening in brain signals. For supporting for the same, what are the general data sets which is available in real time. So this is also supporting deep as also generally one of the common data set which is used in real time. This supports for the sentiment analysis and IAPS and SEED based on the visual trajectories. What are the variations which is happening that can be SWED data set will be make use of it. And there are different kinds of data set which is available to support for the same as Iranian movies and AVRS, DECAF. All this are the real-time data set which you can work with as an introductory person into the level of neuromorphic computing devices. You can make use of the same. And these are the top 10 conferences generally involved with or working out with the area of brain-computer interfaces and neuroanalysis. So these are specially exclusively into the form of neuroanalysis and brain-computer interfaces. And there are fuzzy method exclusively for fuzzy method, fuzzy interface or fuzzy interpreted IEEE, which is also happening. So fuzzy related any papers combined with the neuroscience, if you want to club it, you can make use of it. So this particular conference can be make use of all this particular opportunity. And these are related with the top 10 companies which will be working on the basis of brain-computer interfaces. Apart from this, NextMind and NeuroCity, here IBM is also having its cognitive department, well-established brain-related research is happening in their companies also. And Control Labs is also another one of the top 10 listed company. There are more, but few are listed over here, which is familiar and excellently working with the technologies associated with the brain-computer interfaces. And these are the top 10 books which you can refer and get it insight related with the neuromorphic computing devices. And the next thing is related with the different algorithms, where we will be making use of different machine learning algorithm for classification. Classification can be done on the basis of support vector machines, K-nearest neighbor, deep learning methodologies. Apart from this, these are the traditional methodology as using it. Apart from that, deep learning is also another scenario which provides the performance as in multiple accuracies related with the traditional system. In terms of classification algorithm, if you compare it, deep learning provides slight more variations in the accuracy which is provided by the algorithms. So there are few different algorithms or top level of algorithm which is mentioned over here. Apart from that, DeepCNN, LSTM, and multi-layer perceptron, these comes under a different artificial neural network methodologies. So these are supporting for the deep learning systems. So being though in an introductory person for the neuromorphic computing devices, I would suggest you to go for the traditional system with traditional machine learning algorithms to work it up with. And these are considered to be the top 10 people. They are working with brain-computer interfaces. Their papers can be referred, which is freely available in the internet. You can make use of the same. And there are multiple tools. Top 10 tools is also available. Related with the deep learning, TensorFlow will be providing excellent results. And apart from that, you can make use of either the support of the tool MATLAB or Scikit, also related with the language implementation can be used it. Python also. So whichever particular tool you are familiar with, would suggest you to take that particular tool and work it up with one or two signals, and how things are getting implemented. You need to trace it up accordingly. And these are the following references. Now, a few references to help you out if you're working it up with the general neuro brain computer interface section. And any question, I think I haven't taken much time related with the presentation, right? So these are considered to be the basic building blocks have to be followed. If you work with brain-computer interfaces, this motivates towards the direction of neuromorphic computing devices. So any question you can ask and clarify it right now.
Audience, if you are having any questions, please put it in the chat box or unmute yourself and ask. Ma'am, there is a question in the chat box, ma'am.
Okay. As you said, EEG is the best way to decode the emotions. But EEG is generally done by making the person in the rest mode where he is not allowed to move. How it will be useful to detect emotion. Then in a recent talk, I heard neurologists said EEG is done for a patient and the report seems to normal, but he may get seizure and epilepsy, etc. So in what way it will be useful to say? So this was the general, the slides which I have presented over here. It was related with the defects we were working towards extraction of sentiments from the text documents. I have very clearly specified over there. It was completely related with extracting the emotion from text documents. So related with while reading the content of the particular book, how it will be getting represented. This will be seized on the basis of EEG or neuro imaging techniques very clearly. So the one which you are talking about, it's patients, how their behavior will be changing on the basis of the rest mode and when they are acting. These can be, this will be depend upon, the variation will happen when you will be testing this with a particular patient and general category, and people, those who are working with the industries. Or here we have combined the particular concepts in terms of depression, people, those who are working already. So this has been not how the symptoms they have perceived it, or the accuracy of the symptoms relating with conveying these particular information while reading it, and their strategic level of modes will be variating it. So people, those who are working under this system or working employees, and a set of data you are collecting it from the patients, that resultant might be varying it, because the stimuli you are collecting for a patient's, it will be entirely different from the text document and the other documents or other stimuli which you will be receiving. What are the math codes one need to know to master brain computing? Math course, in the sense, your question is not clear here. Math course, in the sense, introductory signal processing can be adopted. If you are learning with the math course, automatically the basic computer skills also you will be having it. Hope so. So it will be easy. There are a lot of introductory signal processing using imaging techniques which is available in real time, and there are a lot more. Online courses like Coursera, Udemy, they all are providing, and Harvard system is also, university is also providing online courses. So these are the basic system. Otherwise, you will not be able to get a proper hands-on system. You will not be able to retrieve it from. So I repeat, there is different online courses which is available to understand the basic skills in signal processing that need to be get adapted, and the particular characteristics which is shows by a patient, get it separated, that data set, and those who are working with these are the general scenarios is variating. I have told people working with IT industry and their responses towards the depressive modes are varying, and the patient's database if you are taking and testing now, these two are generally variating in multiple ways. So if you are creating the neuromorphic systems to get adapted with different domains and environments, how these emotions and stimuli are getting varied, That has to be traced up first. Hope your question is clear, because you have mentioned over here this in terms of a patient. And the one which you are talking about, it's completely related with the perception of a neuroscientist or a neurologist. So they will be moving towards the direction of neurophysiology. They'll be having multiple number of quantitative data, and it's a biology, moreover, it's a biological data. So we will be moving in detail related with, apart from this brain signals, if you compare, I have already told you, if you compare brain signals, EEG, we are currently working only on the basis of EEG signals. If you club EEG and NIRS, spectroscopic images, if you club these both together, that indicates, is there any specific variations which is happening in hemoglobin according to the brain activity. If you club these two domains together, it can provide more than that brilliant results for the same. So I hope put it the data set related with the patient's data set separately, and other related perceived environment data set, put it in a separate way. So because domains, this will be, the resultant will be generally depends on the different domain also. The one which you are talking about, he might be dealing with bioinformatics. So that's the reason they are saying as EEG is done for only a patient, and they will be generally showing different characteristics, and EEG will be beneficial only while in an while they be in a resting mode. So we will be generally taking care with people, those who are reading, and their mental abilities or mental brain signals are how it will be variating it. A special concentration is towards IT people. Okay. So hope your doubt is cleared. Any more questions? Please clarify it.
No more questions, ma'am.
Okay, sir.
Okay, thank you, madam. On behalf of the Postgraduate and Research Department of Mathematics, Dwarakadas Govardhan Das Vaishnav College, Chennai, I am happy to thank our resource person, Dr. Asha K, wholeheartedly for enlightening us with their interesting facts in neuro-inspired computational brain intelligence for digital transformation. It gave us deep insight into the topic and also revealed interesting facts. The presentation were well organized and explained well with basic concepts. I am pretty sure the precious information shared with us will definitely help all of us in exploring the concepts in future. Once again, thank you, madam.
I thank the coordinators of the program, especially Dr. Venkatraman, for providing an opportunity to share my perception over here. So thank you, sir.
Thank you.
Thank you.
Thank you. Audience, afternoon session will start at 2 o'clock.